So this is my quarantine project. I sold the 2 horsepower prototype machine that I had here, development frame, that ended up, I changed the frame and now this is the production version for the moment. I'll make a handful of those probably. This is my original spindle motor test frame. That is a 3 horsepower, 24,000 RPM spindle. I've been running this thing for over a year, maybe close to a year and a half, and I had trouble with the drive wheels. Obviously, at 24,000 RPM, you really have to have them balanced. And I had difficulty. I made some myself. I had some local shops make them. Couldn't get them to the tolerance that I needed to keep vibration down. Finally found a place that can do them. These are D2 tool steel, one piece, crowned, hardened drive wheels, steel drive wheels. In configuration, I've been, like I said, been running for a year and a half by now, and it has excellent top-end power, very good mid-range power, good bottom-end power. I mean, it's a very good smooth delivery all the way up to the top end. It's a 400 hertz motor, so it doesn't have the power drop off as you overdrive, which means that on a motor like this, it's a 60 hertz motor. When I start to overdrive that above 60 hertz to get higher RPM, then I begin to lose horsepower, or I begin to lose torque. But the motor here is big enough and it has enough excess torque that even though I drive these at 76 hertz, they still pull very good at 7,000 surface feet per minute. Above that, they start to peter out and can't keep up because of the way the power is delivered in those. The 400 hertz, I have a 400 hertz VFD. It's a linear power line that goes straight up so that at the top end, you're delivering top power. This thing, when you're at 60 hertz, is where you're getting top power, and anything over that, you're starting to lose power or torque. This one gives you top power at top speed, medium power at medium speed, and at low end it has very good power for low end tasks. If you need to do heavy grinding or heavy removals, faster is the way you do it. If you want to, find yourself bogging it down, that means you're running it too slow, pushing too hard for the speed, and that you would need to speed up. I don't know if I mentioned it yet already. I clocked this at with a laser clock, a laser tachometer at 3022 RPMs on a 10-inch wheel. So you can do the calculations yourself. I'll go ahead and run it. It's got the actuator on it. Don't mind those ugly welds. That one, I don't know what happened there. It had some contamination or something, and I haven't cleaned the rest off yet. Been in a hurry today, just to get something done this evening. We'll go ahead and plug it in and fire it up. Alright, so we got it powered up. This is a high production machine. If you're worrying about the noise at this type of, at these kind of production levels, then you're probably not the machine for you. Maybe not the hobby for you. We'll try it in reverse. See how we do. See if we spin the belt off. Well, tracks in reverse good. My other wheels weren't able to do this. It's nice to be able to do that. So it'll run forward and reverse well. And see how it does here. We'll do some tracking adjustment. So it moves over okay. Comes back. Alright, we'll swing it forward. Reverse. Okay, now we're in forward position. We'll start out slow. Might need to adjust tracking. Okay, got it centered up. Make a run for it. I have the VFD turned so that it runs, accelerates slow. It's just easier on the VFD. It's running in hertz, reading in hertz, so that's about half speed at 208 hertz out of a 400 hertz total. Sounds like a jet taking off. Now it's up in. Here I got a decibel meter. We'll check it and see how loud it is. So I'm talking at arm's distance, and it is about 70 voice. We're up to half. So at ear level, we're at 82 at half speed. Oh, 86. Oh, that's why I'm talking loud.